Okay, we're going to solve another initial value problem using the Laplace transform technique. So we're going to solve the following second order equation given as follows with its two initial conditions shown here. So we'll take the Laplace transform y double prime minus the Laplace transform of 6 y prime plus 9 and the Laplace transform for y and the Laplace transform of t squared e to the 3t. For this is just s squared y of s minus the initial conditions y of 0 minus y prime of 0 minus 6 s y of s minus the initial condition y of 0 plus 9 y of s is equal to the Laplace transform of this, which is just 2 factorial all over s cubed, but we have a 3t here, so that's just s minus 3 cubed. Now let's substitute the initial values here. We have s squared y of s minus 2s, where y0 is equal to 2, minus y prime 0, which is 17, minus 6s y of s, minus minus is a plus 6 y0, or plus 12, plus 9 y of s. We'll factor out the y of s, and we'll put the initial conditions on the other side. So that's s squared minus 6s plus 9. And on the other side we have 2s negative 17 plus 12 is equal to negative 5, and putting it the other side makes plus 5. And then we don't forget this one, 2 factorial is just 2 over s minus 3 squared. Now we divide by this factor, s squared minus 6s plus 9, so that leaves ys is equal to 2s plus 5 all over s squared minus 6s plus 9 plus 2 all over s minus 3 squared s squared minus 6s plus 9. Now we recognize s squared minus 6s plus 9 is simply s minus 3 squared. So we rewrite this again as 2s plus 5 divided by s minus 3 squared plus 2 over s minus 3 raised to the 5th power. Okay, first we note that this first term here we already did, and we found that we can expand that already to y of s is equal to 2 over s minus 3 plus 11 over s minus 3 squared plus 2 raised to the s minus 3 to the 5th. Now we recognize this. To get it in the proper form, this will be a 4 factorial, and we'll divide by 4 factorial. Okay? And we note all this is like a translation property with e to the 3t as the function f of t that will be found. So we'll take the y of t will be the inverse Laplace transform of y of s. And we'll take the inverse Laplace transform for each of these terms. So that would be the inverse Laplace of 2 over s minus 3 plus the inverse Laplace of 11 over s minus 3 squared plus the inverse Laplace of 2 divided by 4 factorial, which is equal to 24. And then we'll just leave this 4 factorial over s minus 3 raised to the 5th power. Now we take this y of t here, and the first term here is just 2 e to the 3t here plus 11 t e to the 3t, and the last term is 4 factorials at the bottom, so we'll simplify that here to be 1/12, and that would be t to the 4th e to the 3t. So our result of finding this Laplace transform for y of s is given as shown here. Now let me just repeat. When we use the property right here, we basically want to find the inverse Laplace transform Laplace transform of 1 over s squared, and wherever there's a s we replace but with s equal s minus 3, and that's the same thing as t e to the 3t. And for this expression here, we wanted to find the Laplace, inverse Laplace of 4 factorial raised to the 5th power, where we replace s with s minus 3, and that gave us t to the 4th e to the 3t. And then we just add the appropriate coefficients in front of the expression here. So we put a 1/12 in front of t to the 4th e to the 3t, and 11 in front of t e to the 3t.